Hi everyone. So this is me, Brent, recording this lecture again because my file accidentally was corrupted when I recorded during class, so I'm going to be recording this separately and reposting this. So this is the lecture on version control. So I want to begin this lecture by talking about what version control is with an analogy to a bank account, and then give an example of how you can use version control to upload files to a remote server, specifically for this course for the graders and I to review your projects. So first of all, what is version control? Well, it's a way of tracking changes to files, specifically, well, usually source code files, but really you could use any kind of file. Now, this is very prevalent in real-world software development. Many software developers use version control systems, most often Git, to manage complexity across large code bases, to track changes across time, identify when bugs may have been introduced into a large program, and to facilitate collaboration between many members of a team of individuals all working on the same code base. So to explain this with the way of an analogy, consider you have a bank account with some bank. I use Chase, so I have a Chase bank account, let's say. And you have a transaction history. We'll say that you have an initial income of $42, you spend some money on gas, on food, and then perhaps your employer reimburses you for some of these costs so that your total is that $31 we saw earlier. You don't need the balance at any point because you have the transaction history which you can sum up to achieve the total at the bottom here. So version control exploits this fact with code and with files. If you have the changes necessary to achieve a certain state in the program, you don't need to maintain copies of each individual component of the program. And this is the idea of version control, recording each version to a log and then documenting developer descriptions of a change. So imagine, again in the bank account example here, in a real world bank account, you don't have just transaction numbers, you actually have labels describing what each transaction was for. So here we have a description. Your real bank might have a more thorough description, like saying you got gas at Wawa or at Costco or something. Likewise, with code changes, you want to provide a clear description of what that change does. So now I want to get into the first example of this lecture. And I'm going to be using my terminal here on the right to show this. I'm going to show this file I've created called hello.c. As you can see, it's a simple hello world program. It just says hello.c or hello world. I'm going to copy this file using the command cp that we saw earlier in class on our second lecture to create a file called new hello.c. Now I'm going to open this new hello file. I'm going to go down to the directory here, and I'm going to change, or file here, line here, I should say. And I'm going to change the contents of this line to, let's say, goodbye world instead of hello world. And then I'll save and quit that with the vim command :write quit. And now I can run this command diff to see the difference between these two files, hello.c and new hello.c. And it should be visible here. Diff shows you the line number and then the column number of the change. And diff really only works via lines. So this less than sign here signifies that a line is present in the original file that is not present in the second file. This greater than sign signifies the new line. So really, even though it's a modification of a line, to diff, it's as if you had thrown out this original line and changed this, added this new line instead. And the differences start at column 4. And that's because if I go into my file here, you can see it's indented, which is indented by 4 columns because it's a tab character, so it's actually 4 columns. And with diff, we can actually create a patch, which is sort of like a transaction that we can apply later to change one state of a file to another state. So I'm going to do that now. I'm going to run this diff hello.c, new hello.c, and I'm going to use this greater than operator to redirect the output of diff to a file I'm going to call change.patch. And if I cat out the contents of change.patch, you can see it is exactly the diff that we saw earlier. And I'm going to copy hello.c to patched hello.c file. And the reason for this is because patch inherently changes the input file. And actually, there's a way to around this. Maybe I can change the example here. If you look at patch and then go to, let's see here, flags, there should be a flag. Maybe it's options, actually. Options. There's an option here called, let's see here, probably -o, -i, -o, right here, -o, out file. So this will tell patch to apply our patches to a specified out file. So I'm going to say patch hello.c using change.patch, and I'm going to make the out file patched hello.c. And now if I cat out the contents of patched hello.c, you can see that it actually has the contents of new hello, because we applied the patch to change hello.c to have the contents of new hello. And you can actually run this in reverse. So if I were to run patched hello.c and pass it change.patch and say yes to this, so I'll just type in enter. Oops, let me run that again. Yes, and then cat out the contents of patched hello.c. It actually reverts the change. So patch is sophisticated enough to know that if a change has already been applied and you're trying to apply it again, you can reverse it. And to ignore that warning message that we saw, I could actually pass here patched hello.c, change.patch. I'll run it again so that the change applies, and then I'll pass the dash reversed flag. Oops. Maybe it's reverse. Let me try that again. Reverse. And now if I cat out patched hello.c, you can see that it reverses it. And that just ignores the warning message when you're undoing a change. So we can visualize our set of changes as a chain, a sequence, or maybe a linked list even, of changes from one file to another in order to achieve the final state of a file that we desire. This is like that transaction history again. And this is the idea that Git uses, so Git is a very popular version control system, to implement itself. So under the hood, Git might be more complex than just a simple sequence of diffs, but conceptually that's all Git is doing. And this book here, Pro Git, is online for free. If I click the link, it will take me to the page. You can check it out. I haven't read it myself yet. I would like to one day, but it's a very long book and seems very interesting, actually. Probably a lot of information here that would be useful in a career in software engineering. Let me quickly return to where we were, right here. So now I'm going to actually create a Git project, or, well, I won't create the Git project yet, but I want to show you the idea of how Git works conceptually. So we have a working directory, which it contains the files you're currently modifying, a staging area, which contains changes that you have staged for being committed to the repository's local database, and by local I mean on your machine, not in the remote, or on the machine you're SSH'd into if you were on Eustace, for example. And once the files are committed, they are in your local database, local repository, and then you can actually push those changes to a remote repository or be backed up. And I have some diagrams here from the Pro Git book. They're good in context. They're more illuminating. Here it's maybe a little bit harder to follow. And again, this is all distributed, so you can have multiple computers working on one project and pulling from the same remote to keep your changes all up to date. And I'm going to give an example of this shortly. Some commands you would use to modify each one of these steps. Let me show you here with an illustration now. So I have on the left here a diagram that hopefully illustrates all these key points. If I were to create a directory here, let me delete everything but hello.c. So remove change.patch, or actually, I think what I'll do is remove this hello directory, go into COP-3402 Spring 26, and I'm going to start working on the version control exercise, because this provides space for me to demonstrate all the concepts we've been reviewing so far. So let me go back to this table here, and I'm going to start working through this version control exercise because it will allow me to explain this idea better with an example. So we'll go to the overview, and I'm going to run this command first, SSH. Actually, I've already run it. I'm already in my Eustace account. Git configurations. I've already configured my Git with these commands. I recommend following them yourself so that you configure your Git defaults to have your username and email. You can configure Git to have an editor for commit messages. I recommend using Emacs, use Vim. I recommend using Vim. I also recommend using Emacs, actually. Emacs is a great editor, too. I prefer Vim. You won't go wrong with both of them. Vim is a little bit faster than Emacs to start up. Also, if you run this command, you can avoid having an annoying warning message appear whenever you create a new Git repository. And actually, we're going to do that now. So I'm going to run this command to create a repository or a directory on my machine here. And the -p flag, if you're unsure what that means, you can look up the man pages for make dir. -p is for parents. So it emits no error if a directory already exists. And if it doesn't, it will create parent directories as needed. So now we have this VC directory. I'm going to cd into it. Nothing's here yet. There's also these validation steps you can follow to check your work as you follow along with this assignment. I recommend following them. However, I'm going to be skipping them for this video. And now that we're in the VC directory, I'm going to initialize a Git repository here with the command git init. You can see this command ran, and if you run ls, you'll notice nothing seems to have changed. But if I do ls with the -a flag to show all files in my directory, including hidden files, you'll see there is a hidden .git directory. And this is really all Git is under the hood. It's this .git directory that is keeping all your diffs and changes and history and whatnot. I will run this validation command to show you a useful Git command, which is git status. I recommend running this frequently to see the status of files in your project. And as you can see, we have no files yet, no commits or anything, so there's nothing to be shown. So I'm going to run this command next to create a README file. And what this will do is echo out the words VC project and redirect the output to a file called readme.md. So if I cat out the contents of that file, you can see that it is exactly what we had passed to echo up here. And now if I run git status, you'll see that we have one untracked file, readme.md. So now I'm going to go back to the illustration here, because this is perfect for the illustration. I'm going to change this text to orange, and I'm going to create a file here called readme.md. Currently, readme.md is in our working directory. It's red here on the right because it is untracked. I can run the command git add to add readme to the staging area. You can see it's green now, so conceptually we've moved readme to the staging area. And these are really all just files in your machine. Really everything is in the working directory, but conceptually it's now in the staging area. Readme is now in the staging area. If you want to move readme back to the working directory, if you find that the changes you made are not ones you'd like to commit, you can actually run this command that gives you as a hint rm cached readme. And now if I run git status, you can see it's back in the untracked working directory area. So it would go back here. But I want to push this, or I want to commit this, so I'm going to add readme to the staging area. Put it back over here. And let's go back to the project instructions. So the next instructions were to add it, we've already done that, and then to commit the file. So I'm going to do that now. Git commit readme. I'm using tab completion to go faster. And this is going to bring up my editor, asking me to enter a commit message. And it seems to be loading. Okay, there we go. I will say initial commit, or you could say add readme. Whatever you want to put. I recommend putting a short message that uses the imperative voice, so the commanding tone, present tense, saying what the commit does. I'll say add readme. And now if we run git status, you'll see on branch master, nothing to commit, working tree clean. We have no changes pending. We are up to date with our repository's database of changes. So readme has gone to here. Now I want to go down to the next step here. Oh yeah, we can also run git log. So this is a good command to know. or git show, I guess. Git show shows you the previous command. I'll run it again here with a clear screen. It gives you the message and tells you basically what was done, like a summary of what was done. We created this README file with the VC project. This just shows the most recent command. You also have git log, which shows all previous commits, like the history of all commits. So if we had made more commits, they would all appear here in sequence. This is useful when you're working on a large project and want to see what all the recent commits were. There's also one more command that I think is sometimes useful, which is git commit amend. This lets you change the commit message of your most recent commit. So if I wanted to change this to initial commit, I could do that like so. And now if I run git log, you'll see the commit message is now initial commit. Git commit amend is a very small command. You don't use it often, but it is useful for fixing typos in commit messages. So I bring it up. Now we're going to add the remote repository URL for this assignment so that you can grade it. So I'm going to add the remote here using this command. I'm going to copy it, and then I'm going to explain what it does after I'm able to copy this in. So let me select the command. And what this has done is, let me actually, this up here, I'll highlight this as I go along. Git remote, so git is the command we're running. Remote is a subcommand. Git has a number of subcommands. Remote is one of them. And underneath remote, there's another subcommand called add. You can read the man pages for all these by checking git man git -remote. And you can see the man pages for git remote. And you can see there's an add subcommand here. And man git will just show you the information for git itself. But you can get information on any of git subcommands by doing hyphen and the name of the subcommand. And you can use tab completion to see all of them. There's quite a few. So as I was saying, this command that we ran, we are adding a remote repository we're calling submission. So in the board here, I will actually call this remote submission in this illustration. And the submission has a URL, which is this URL here. So what is this URL? Well, the part before the @ sign is the name of the user we're logging in. Well, actually, let me start with this part, I suppose. The part after the @ sign is the name of the server we're logging into. So we're logging into UCF 3. That is another server at UCF, which we're going to be using for holding our grading script, or some project submissions, I should say. The user we're logging into under UCF 3 is Gitolite3. This is the service we're using for having our own Git repositories for remote uploads. And after this colon signifies where underneath this user's account on this server we're going to be storing these files at. So we're going to say underneath COP-3402, underneath the user VC directory, we're going to be storing our remote repository at. And this user $user is actually a shell variable. So if I run it, it will expand. If I type echo and pass the user variable here, it will expand to my username. You don't really need to know this. You can just copy and paste these commands, but it is useful to kind of know this. And what's kind of cool is that tab expansion will also work with the user with variable names in Bash. So you can actually expand that. So we've actually added the remote. And you can actually verify that this has been added by running git remote-v. And you can see it exists. And the name of the remote is submission. What we're going to do now is push our changes to this remote. And we're going to use this command here to do that. Let me just make sure it doesn't run when I copy it. So git push is another subcommand of git. And we're doing the set upstream flag. I'll explain that in a second. We're pushing to the submission remote from the master branch. So the current branch we're on is master. If I run git branch-v, you can see we're currently on the master branch. That's why it's highlighted in green. And here, to copy this command again, we're pushing from the master branch to the submission remote. And this set upstream flag, well, that just means that we want the default remote for master to be the submission remote. So in the future, we can just run git push, and if we're on the master branch, Git will know that by default we want to push our changes to the submission remote. So conceptually, what we're going to do is move this README file, actually not move it, but copy it to the submission remote. But let's try it and see what happens. You'll see that I got an error, and I was expecting this. You will not receive this error when you go to perform this project yourself if you follow the steps correctly. You might receive it if you make a mistake. And the reason for this error is because I didn't tell you this before I started giving this lecture, but I actually already had a README file present in the remote because I've done this project before. I'll make it in purple to signify that it's different. There's already a README file that exists. And so when I try to push my README in my local repository to the submission remote, we have an error because Git cannot rectify the differences for us. It's as if, again, going back to the bank account balance, you wanted to tell your bank to overwrite your transaction history with you starting at $1 million. The bank is going to prohibit this because they have their own transaction history that's actually correct, and you probably do not have $1 million, unfortunately. So how can we fix this? That's probably what you're most concerned with. Well, the way to fix this is to call this hint here, run git pull before you push. So I'll run git pull, and let's see, no common commits, enumerating, tracking information for the current branch. Let's see if I can run git log and see if there's any changes here. No. What I'm going to do is run, or actually, sorry, I have to specify what I'm pulling from. Submission to master. So I'm going to run that again. You'll see we get an issue here because we have divergent branches. So these are merge conflicts. This is the problem. The problem arises because now we're trying to turn this one-way arrow into a two-way arrow. So let me flip this over to signify this. But we have two files named readme.md, and our commit histories are different. So how can we rectify this? Well, there's a few different ways. You can configure Git to use one of these different methods. I'm going to just use this rebase method. I'm going to copy it in, paste it. You shouldn't have to do this. Again, if you follow the instructions for the assignment correctly, you shouldn't have to do this. But if you do run into an error, you can follow these instructions. Just follow the hint, copy one of these options. I'm going to choose rebase, and then run this git pull command again. And now you'll see we got a warning, but it worked with this warning message. I'm not going to go into the details of the warning message. It's a little too advanced, I think, for just this lecture, but what's important is that this command actually worked. And now that it worked, we have overridden the contents of our readme.md with the contents of the readme.md in the remote repository submission. And now if I run git log, you can see I have the transaction history that was already in my remote. So now I can make a new commit. Let's go back to our readme here. I'll say new commit on, and then what I'm going to do, to be kind of fancy, I'm going to run this command to read the current date into my file directly from within Vim. And now I can see git status. I have a change pending. I'll add that change. I'll commit it. I'll say make new commit, or add timestamp to readme. Let's say that. And now I can push this change. Oops, now I can actually set the upstream. Remember, I haven't set the default yet because the command didn't work when I tried to run it before because I had conflicts. Now I can actually set the default, run this command. It will work, and in my status, I'm working clean. So how can we check that this actually worked? Well, what we can do is we can run git clone to create a new clone of the repository, of the remote repository. So I'm going to copy this command here. I'm not going to run it yet. I'm going to change something. This one on the bottom here, this square in the bottom, is the VC repository. But if I wanted to make a new copy of submission that has all the changes that I've uploaded from my original local submission, I'll actually just delete this here. I can create another local copy of the repository. In fact, I can create as many as I want, but I'll just create one for now. And I have to give this a directory name. So if I try to run this now, you'll see that I already have a directory named VC in this current directory. But the command that I'm trying to run, if I do decide to run it, will try to clone the contents at the given URL, which is the same URL we had used for the remote repository submission. And if I try to run this, we'll get an error because the VC directory exists and is not empty. So the way around this is to just change the name of the directory that Git is asking you to that you're telling Git to use to place the clone at. So if I run this, it will now work. You can see the VC check directory now exists, and if I run git log, it has all the changes I made from before. So now we've successfully created this second local repository in this illustration. Let's see, I think that wraps up the lecture. So if you have questions or if you have any problems, feel free to come to my office hours or post a question on EdSTEM. Again, I recommend checking out these validation steps, running them, and if you run into errors, we have a bunch of errors already accounted for in this assignment description. I didn't run through all the steps of the assignment, so I recommend following, well, you should follow all the steps to get full credit. I just showed some of the basic commands. And that wraps it up. So I'm going to end the lecture here. Good luck. I'll see you all for the next lecture.